Let's talk about latent nodes in Unreal Engine. Latent nodes are nodes that get executed, then do their task, and then only once that task is completed, will move on in your blueprint graph. So these are nodes that will store your blueprint until such time as they are completed. One that you might be familiar with is the delay node. You enter it, it delays for a set duration, and then it completes. These are distinctly different from async nodes, which are tasks that can run while other code also keeps running. So in this situation, we can have a delay with interval, where the top pin immediately starts executing whatever is next, and then we have other output pins that can, on arbitrary logic or intervals, also execute their own outputs. And async nodes also have the capability of being run on a separate worker thread so that they don't interfere with your main game loop, but that's something that we'll talk about a little bit later. So we're going to make a little bit of a mini-series here with 3 videos, one on latent nodes, one on async nodes, and one on dispatching a worker thread. Starting with the latent nodes because they are the most straightforward. You just enter them, you do some work, and then you move on. You do require C++ in order to set up custom nodes of these types, but we're going to walk through this one step at a time. So we're here in an entirely empty project, and we're going to effectively set up the nodes that you just saw in my example project from scratch. So let's open up my IDE. I'm using Rider, which is an amazing IDE for game development. There's a link down below in the description if you want to test it out. But you can, of course, use just Visual Studio Code, whatever you prefer using. For a latent node, what we're going to do is I'm going to go ahead and add a Unreal class. This is why I like using a Rider. If you don't have a Rider, of course, you can just go into your project, C++ classes, and make a new class. And there in all classes, what you're going to look for will be the blueprint function library. Since I'm using Rider, I can do it from my IDE, which is just a little bit more convenient. So we're going to do blueprint function library, this one over here, and we'll call this latent lib for latent library. And the way these work, these latent nodes, are that they are their own separate classes. So we're going to make a class within this file, specifically for this one task. And then when we run whatever function we want to run through our blueprint library function that we're going to be setting up at the very end, it will create that object, which will take care of doing all of the actual stuff. So we'll go under our U class, so outside of everything else. And this is just Copilot. We're going to ignore that for now, even though it is actually kind of right in what it's suggesting. We want to make a class. We don't need to mark this as a U class or anything like that. It's just going to be a C++ like vanilla thing. And we'll call that F. And in our case, we'll call this latent move actor. And that's going to extend public F pending latent action. And we'll do our curly brackets and our semicolon to make this a class. Now, we want to take in some information to do with the latent task itself, and then also some information to deal with whatever this task is going to do. So let's set up the latent information first. First and foremost, we have an fname, which will be the execution function, then the integer 32 for an output link, and then a fweek object pointer for our callback target. Don't forget the semicolon after each one of those. This is just some stuff that the latent action is going to provide us with. We don't really need to worry too much about setting all this up. We just need to take in the information and send it through to these variables when we actually get it, which we'll get to in a moment. Then, since we're actually making a function here for the example, moving an actor across a certain distance within a certain amount of time, we also are going to take in a actor to move, the location that we should move it to, and the amount of time that that should take. So we create a tweek object pointer for the actor target actor, or just a normal actor pointer should work as well. I'm trying to get myself in the habit of using weak object pointers a little bit more because they're a little bit safer to work with. Then we have a start location, because we're going to need to interpolate between where it starts and where it ends. and a desired location, which is going to be its destination. We have a duration for how long it's going to take going from A to B. And that's going to be all for now. We're going to put all of this under being public as well, so that we can access it from elsewhere if need be. Then we're going to set up the constructor for this class. So we create a constructor by just making a function with the exact same name. So f latent move to actor, and that's going to be taking in quite a few parameters. So we're going to list those under each other so that you can all have them on screen at the same time. A actor pointer for the in target, the f vector for the in desired location, the float for the in duration, and then a const reference for f latent action info. So const f latent action info and %sign for it being a reference, and then in latent info. Those are the arguments that the constructor is going to be taking in to fill out all of the information that we want to set in these variables up here. Then rather than doing a semicolon, we're actually going to do a normal colon, because we're going to then set all of those values right away. So we'll set the start location, which is the variable that we set up here. We're going to set to being our in target actor, get actor location. And then we get our desired location will be our in desired location, our duration will be our in duration. So we're setting these values based on the parameters that we given in from the constructor, which will be constructing the actual object in a moment. And then next up, I guess we set the target actor to being the in target actor. And this is the information that we are going to need to actually run the functionality. And now we also need to add in some stuff to set up the latent action itself, which first and foremost will be the execution function. So that's going to be the top one that we made at first. And those we get from the in latent info dot execution function. In this case, we set our callback target to being the in latent info dot callback target, and then the output link indeed to in latent info dot linkage. And then we do add some curly brackets for the actual constructor code, which we're going to just leave empty. So this will be the constructor for this class. Below that, we implement the actual code that's going to run in this latent action. And we do that in the function called virtual void update operation. And that has a parameter of f latent response reference response. And it's going to be an override, of course, because it's overriding another virtual function. We're going to just implement that in the header file here right away. You can, of course, do that in the CPP file if you wanted to, but this is such a straightforward and small thing that I like to just all have it contained within this one class within the header file. First off, of course, we want to check if our target actor is valid, because if it is not, we response done if true. So this is just a way to finish your latent action. So if we give in a invalid actor here, we're just going to immediately finish, and we can return this update operation so that it doesn't run the rest of the code either. But if the actor that we're giving it is valid, we can start doing some actual stuff. So we want to make a float for a alpha, which will indeed be math, and will not use a time elapsed variable. What we'll do instead is we'll directly get the response dot elapsed time. So this is the amount of time that has gone by since the start of this latent action, and we're dividing that by the duration to get a 0 to 1 value that we can use as an alpha to lurk between the starting location and the desired locations. Going in here quickly during the editing, I made a tiny bit of a mistake copying over from my reference project. We do need to also have a float in here for the time elapsed. We can just in the constructor set that to a default value of 0.0. You can always skip it if you really want to. It's nice to just explicitly set this to 0 just in case. And then in here, instead of just getting our response.elapsed time, this is kind of like your delta time, not the total elapsed time. So what you do is instead you make your time elapsed plus equals the elapsed time, and then you use the elapsed time divided by duration, and so on and so forth. So that'll be what we do next. We do f vector math lerp from the starting location to the desired location with the alpha that we just calculated. And then we can use the target actor to set actor location to the newly calculated location. Quite as simple as that. After that, we just check if our alpha that we just calculated is greater than or equal to 1. We're actually clamping it to 1 anyway, so you can just check whether or not it's exactly equal to 1, but it's always like good practice to check greater than or equal to just in case. So we'll do that, and then we do a response dot trigger link, and this will trigger the execution pin for the output. So we give in the execution function, we give in the output link, and we give in the callback targets. And then we also do response done if true to actually finish this latent node. So as you can see, we make these values, and as I said, we just populate those values by the latent information that the engine provides us with, and then we just use those to trigger the output pin. You can technically set these up, I believe, to have multiple different output pins as well. And at that point, you might need to start messing around with having like different execution functions and output link values and all that kind of stuff. But if you're going to do that, 9 times out of 10, you're probably better off just making an async node anyway. So I wouldn't worry too much about that and just let the engine like providing that information and just pass it through back when you're done with it. You don't actually like need to do too much with this. So this is setting up the task itself, the action. Now we need to make a function that lets us create and run this from Blueprint. So finally we come back up into the Blueprint function library, the uLatent that we made. And here we add in another public section where we will make a U function. And that U function is going to be Blueprint callable. And we'll set up a lot of meta stuff. So meta equals, we're going to put into parentheses here. First and foremost, we want to set this to being a latent. Next up, it wants to have a variable name that it's going to look at to gather up the latent info. And by default, it provides you that as, in quotations, latent info. We're going to just use that as well. It wants a similar thing for world context. So it needs to have a world context object to work properly, which is going to be like any object or any actor that you can give in. And it's going to grab whatever of your parameters has this exact name. So it's going to be target actor in our case. And then we can just set a category to be, it says test latent here. Let's call this like tutorial latent. And then we make this a static void move actor to location. And that's just going to take in the a actor pointer for target actor. It's going to take in the f vector for the desired location. It's going to take in a float for the duration, and then it's going to take in a f latent action info for the latent info. It's not actually going to show this in Blueprint. This is going to just, again, be provided by the engine for you. And all this meta stuff is just going to look based on the names. Hey, we have latent info. Oh, that's this parameter, so it's going to grab that one. Again, provided in by the engine. World context is going to grab the actor that we provide in because that's how we set this up. Now, let's implement this. So I'm going to just, again, using Rider's little shortcut here, I can easily implement this into the CPP file. And here we also just start off by checking, hey, if the target actor is not valid, we immediately return because we don't want to do anything. And then we check if the URL pointer, which we'll just call world for now, maybe spell it properly, that helps, which we'll get from the G engine, get world from context object checked, and that's going to take in our context object, so that will be our target actor. And this immediately also checks the validity. So this does two things. This makes our local variable for within this if statement, and if this ends up being not valid, it also works as a validity check on this pointer to begin with. So quite a nice way to both make a variable and then also check the variable at the same time. And this is just checking effectively if we can get a world reference from our context object, which in this case, because we're providing in an actor, this effectively will always work because we're already checking whether or not the actor is valid, and actors will effectively always be able to give their context world. So this is a little bit overkill, but better be safe than sorry, right? Within that though, we're going to get our f latent action, and we're going to get a reference to it. We'll call that latent action manager, and we get that from the world that we just made a pointer to, and get latent action manager. So every world, every like level effectively in your game is just going to come with a latent action manager, and that's the thing that we're getting here. So in there, we're going to check, hey, if our latent action manager dot find existing action, and here we're going to look for the exact type of action that we're creating. So in this case, that would be this type, so f latent move to actor, and we'll check the latent info callback target and the latent info UUID. If the return value for that is equal to null pointer, that means it didn't find an existing action already, which means that we are allowed to then create that action and run it. This is effectively just if you go back into Blueprint, right? If you have used a delay before and you do this in something like tick, it's only going to complete after 0.2 seconds, and it's just going to disregard every other like input it gets until it is completed. Because otherwise it would create a new object every single time you give it an input, and it doesn't like really like you doing that. So this is just kind of gating it off. It's going to ignore every other input you give it until it's completed, at which point you can give it a new input. That's what that little line of code does. So let's remove this because we're going to set that up one line at a time, don't you worry. So if we pass that if statement, what we do is we get our latent action manager and we just add a new action to it. This is going to take in a few things. Number one, a callback target, a UUID, and then an object for the actual action that's going to run. So what we do is we just give in our latent info, which we get as a part of what the engine provides us with from the parameters here. And we give in the callback target, we give in the latent info.uuid, and then we're going to make a new f latent move to actor. So that's a new instanced version of the object, the class that we just created. And that takes in the parameters that we need, that we set up in its constructor over here. So if I remember correctly, we can hover over it. That takes in the target, the location, the duration, and the latent info. So we get those sent through from Blueprint. So target actor, desired location, duration, latent info. Make sure to put the semicolon where it needs to go and have enough of these little brackets. And that's pretty much everything there is to it for making a latent node. So as a real quick overview, we have this Blueprint exposed function that is static in a Blueprint function library. So we can now call this wherever we want in our entire Blueprint project. That takes in some of the information that we require, the target actor, the desired location, and the duration. Whatever you do, you always need a world context object though. So even if you're not moving an actor, you probably need to give in just a world context U object. But most of the time you're probably going to be working on some sort of actor with these latent things anyway, so you can just use that actor reference as a result of that, or that actor pointer. When we call this, what it does is it first checks, hey, does this actor exist? And does it have a world that it can provide us with? If so, we're going to get that world's latent action manager. We're going to try to figure out, hey, is this latent action already running? If it is not, we're going to create a new action. And when we create a new action, we give in the proper information, which runs this in the constructor, sets all of these variables on this latent action to whatever we give into it. And then it's just going to keep running this update operation function until we say, hey, done if true. So it's really quite as simple as that. And with that, we can now close down the editor that we had, and we can build this project. And I'll see you back in Blueprint to test out whether or not this works. So here in the Blueprint project, let's open up a Blueprint. Actually, let's not do this on the character because that will be weird. Let's just make a quick little test actor, which we'll just call test actor. give that a mesh so that we can actually see it in the world. Just a sphere will do fine. And then in the event graph, we should be able to find the move actor to location. And it is within the tutorial latent category. So we now do have that. Now it doesn't seem to be providing in the in actor in this case. And the reason for that is that we provided that as one of the meta values here. So it's actually going to take that away from the parameters that you put in. But that should be fine because it is automatically assuming that the context object will be this actor. So whatever object is calling this will get filled in as the target actor. That does mean that if you have like the game playability system existing or whatever, or you want to move a different actor with this node, you can't provide that in. So in that case, you would need to have a separate world context object from your target actor object. I also made a spelling mistake. This does need to say latent, not latent, with an N. So let's recompile that real quick. And now we can see that it has changed into a node with one of these little clocks because I fixed the typo for defining it as a latent node. So it's going to move the actor that this node is running on to its desired location within the amount of time that we specify. And only after that finishes will it print this string. So we can test that. It's going to move from where it is to 000, which is over here. And after that, it's going to print hello, and it's going to take 2 seconds to do so. So we can see that, and then it prints hello after the 2 seconds are done. So that's the basic idea of setting up a latent node. Of course, you can then inside of here, in update operation, put literally any code you want to do anything that you do want. Do keep in mind though that this still is just an object running on the main game thread, so you're not going to be able to do any like super complex things that would usually like take a separate worker thread. That is where async nodes come in. Next time we're going to make an async node that's still going to be primarily running on the main game thread, but then we'll kind of edit it later on to work on its own worker thread. That's not really what latent nodes are for though. It's important to keep the distinction between those two very clear. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sir J. Thomas, and my Cave Student tier supporters, Oiku and Earl Monsville Urno.